The next-generation fighters, currently known as FX, are part of Japan's upgrading of its aging fighter jet fleet as the country builds up its military capability to counter growing threats from China and North Korea. The next-generation stealth jet will replace F-2s that Japan co-developed with the US. They are due to be retired around 2035. Mitsubishi F-2. The F-2 support fighter aircraft is a multi-role single-engine fighter aircraft principally designed for the Japan Air Self-Defense Force JASDF. It is the result of a joint Japan and USA development program. Mitsubishi Heavy Industries (MHI) is the prime contractor, and Lockheed Martin Aeronautics Company serves as the principal US subcontractor. The F-2A is the single-seat version, and F-2B is the two-seat version. The Japanese Defense Agency originally planned to procure a total of 130 F-2 aircraft. Japan is currently developing a new advanced fighter jet to replace the Mitsubishi F-2 support fighter aircraft. The aircraft's integrated electronic warfare system, mission computer, and active phased array radar were developed by Mitsubishi Electric. An M61A1 Vulcan 20mm multi-barrel gun is installed in the wing root of the port wing. There are 13 hardpoints for carrying weapon systems and stores, 1 on the fuselage centerline, 1 on each wingtip, and 5 under each wing. The stores management system is supplied by Lockheed Martin. There are 2 Frazer-Nash common rail launchers manufactured by Nippey. The aircraft is capable of deploying the Raytheon AIM 7F/M medium-range Sparrow air-to-air missile, the Raytheon AIM 9L short-range Sidewinder, and the Mitsubishi Heavy Industries AAM-3 short-range air-to-air missile. The F-2 is armed with the ASM-1 and ASM-2 anti-ship missiles. Mitsubishi started developing the Type 80 series anti-ship missiles, ASM-1 and ASM-2, in 1980, originally for the F-1 fighter. The fighter aircraft can also carry 500-pound bombs, CBU-87B cluster bombs, and rocket launchers. The center line and the inner wing hardpoints can carry drop tanks with a 4,400-kilogram fuel capacity. Subaru Aerospace Company. The aerospace company, by leveraging tradition and innovative technologies, develops and produces a wide variety of aircraft and components for major customers, such as Japan, Ministry of Defense JMOD, and Boeing. As to the rotorcraft programs, Aerospace Company successfully completed the joint development with Bell Textron Incorporated, USA, of the commercial helicopter Subaru Bell 412EPX, which is also utilized as the platform of the new utility helicopter, the new UH, for Japan Ministry of Defense, JMOD. Kawasaki T4. On November 1981, the Japanese conglomerate Kawasaki was chosen as the primary contractor to develop and produce a suitable trainer aircraft, which was originally named as the KA-850, to target the requirements of Japan's MTX program, having beaten out bids from competitors such as Mitsubishi and Fuji. The MTX program had been initiated to purchase an aircraft that will take over the old Lockheed T-33 and Fuji T-1 jet trainer that were in service with the JASDF. Moreover, there was also a need for the planned trainer aircraft to replace some of the syllabus that was being managed by the Mitsubishi T2. The design had to showcase a range of transonic aerodynamic effects and attain a high level of maneuverability, a comparatively low operating cost, and better reliability levels. Smooth handling was also essential so that trainees could convert from the Fuji T3 piston engine after acquiring just 70 flying hours. Out of these modifications and advancements developed the Kawasaki T4, a clean-sheet indigenously developed intermediate trainer aircraft. The Kawasaki T4 has a well-made, damage-resistant airframe that is mainly composed of traditional aluminum alloys, although some portions are also made of composite materials. The aircraft structure has enough strength to enable high-gravity maneuvers, being rated to carry out spontaneous dives of 7.33 g when being flown in a clean configuration. It is equipped with a thick-section transonic airfoil developed by Kawasaki and Japan's Technical Research and Development Institute, TRDI, to give excellent high angle of attack handling and better spin characteristics. An uncommon aerodynamic feature on the aircraft is the tight leading-edge root extension, lurks, forward of the leading edge along the fuselage that generate additional vortex lift and improve the aircraft's high G departure proneness, like the refrainment of wing drop and pitch up while in aerodynamic stalls. It has a wingspan of 9.94 meters and a wing area of 21 square meters. The avionics were made digital to decrease both its size and weight while increasing its reliability. Usually, these systems and components have been domestically produced, despite the fact that some technologies from numerous American industries were incorporated, such as the inertial guidance system that uses laser gyroscopes built by Honeywell, and the air date computer that uses transducers from Sperry. Most of the onboard systems are typical, except for the use of a licensed onboard oxygen generation system, OBOGS, that was considered as an unusual choice for a trainer aircraft and had needed ample effort to suit it for use aboard the T4. Japan continues to offer a lucrative market for imported aircraft parts, and engines. US firms have an overwhelming presence in the market due to long-standing relationships, some spanning over 60 years, with domestic manufacturers and trading firms. US firms are presented with opportunities in the market as the Japanese industry undertakes international projects, develops transport and patrol aircraft for defense, and develops small jets and small jet engines for civil aviation. Fuji T7. Fuji T7 is a primary military trainer aircraft manufactured by Fuji Heavy Industries FHI for the Japan Air Self-Defense Force JASDF. The aircraft replaced the T3 trainer that is in service with the JASDF. The Fuji T7 is used for basic flight training by the Air Training Command and the Air Development and Test Command of the JASDF. The aircraft are currently operated by the 11th Flying Training Wing, 13th Flying Training Wing, and Air Development and Test Wing. Fuji T7 is a longer and heavier variant of T3 trainer. The aircraft incorporates a low-wing monoplane design, including a modified cowling and wing. It integrates a turboprop engine in place of the piston engine used in T3 trainer. The turboprop engine delivers high performance and reduces noise levels. The aircraft has an overall length of 8.59 meters, wing span of 10.04 meters. The wing area of Fuji T7 is 16.5 square meters. The Fuji T7 trainer aircraft has a maximum speed of 376 kilometers per hour. The cruise and stall speeds of the aircraft are 296 kilometers per hour. The aircraft can fly at a maximum altitude of 7,620 meters. Kawasaki. In World War II, Japan's heavy industries would end up going from round-the-clock production of war material to virtually complete destruction in only a few short years. But during Japan's brilliant MacArthur-era post-war reconstruction, Kawasaki's extensive experience in heavy industry developed for the war effort would later be put to use, manufacturing an entire new generation of civilian and commercial machinery. Though Japan was completely prohibited from manufacturing aircraft from 1945 to 1952. In the 1950s, Kawasaki would end up being a leader in manufacturing another revolutionary type of aircraft, the helicopter. In 1922, Kawasaki completed its first airplane at its Hyogo works and conducted test flights in Sohara village, currently Kakamigahara City, Gifu Prefecture. The Japanese Army admitted its excellence based on the test flights and adopted it for the first military plane, the type Otsu-1 surveillance plane. That's all for today. Thank you for staying with us until the end. Subscribe to our channel and see you in the next video.